Hello. Hopefully you can see me. I've just changed all the settings on the stream, so hopefully that's started now. It says it has, so that's good. I'm going to give people a few seconds just to join the stream. Sorry this is a little bit later starting. It was just the time that dinner was ready, basically, so I had to push it back a little bit. Yeah, like I said, I'll give people a few seconds to join and just to sit down and get ready if they want to. But yeah, I'm going to go through today the rest of the 2024 further maths paper. Obviously, any questions, any suggestions of questions that you want me to go through, please let me know. Yesterday in the stream, got up to question 12, did that. So I'm on to question 13 and then finishing the paper. Okay, so I think everything's started. I think it's all ready to go. So I'm going to work through the rest of this paper. And like I say, if you've got any questions, please put them in the chat. Okay, so a garden patio is made from two rectangles. All lengths are in meters. The area of the patio is less than 51 meters squared. Work out the range of possible values of x. Give our answer in this format. So A is less than X is less than B. Okay, so we've got the area, and to work out the area of this shape, I'm going to split it up. So this would be 7x, and this would be 8 lots of x minus 3. So we know 7x plus 8 lots of x minus 3 has to be less than 51. So we get 7x plus 8x minus 24 is less than 51. 15x minus 24 is less than 51. Add the 24 to both sides. We're going to get 15 is less than 75. 15x, lost the x here somewhere. Divide by 15 and we get x is less than 5. Now, that's one side of it. The x is less than bit. We need to have x is greater than. Now, for this bit to be a length here, the x minus 3, x has to be bigger than 3. And so that gives us both of our values. So x is greater than 3 and less than 5. Okay, that's the values that it needs to be between. Okay. Are there any factor theorem questions? Potentially there could be. So if I go back to the questions from yesterday, there was this question here, 11b, which said x minus 2 is a factor of this. Work out the value of a. So use the factor theorem to do that, because obviously if x minus 2 is a factor, x equals 2 is a solution, you substitute it in, equals 0, and then solve it. So yeah, there could be. Okay. Moving on to this question. This is a fairly standard question, if I'm honest, about completing the square. And this is something that really you can have on your GCSE as well. So I'm going to look at these first two terms first of all. I'm going to factorize 2 out of them. So 2x squared minus 8x plus 7. And then, actually, I'm going to change these brackets here to square brackets, just so it's easier to see in a second. It doesn't matter if you use curly brackets, but just so, like I say, it's easier to see this next bit. So then I'm going to complete the square on this. So I have x minus 4 all squared. So you halve the number in front of the x. And then we subtract the number in the bracket squared. So subtract 16. And then we've still got the plus 7. Then I'm going to multiply this 2 back into this square bracket. And we're going to get 2 brackets x minus 4 all squared minus 32 plus 7. And that gives our answer. Yes, this is the non-calculator. Yeah. 2 lots of x minus 4 all squared minus 25. Okay. So that should be our answer there. Like I say, that's a very typical question, straightforward question relatively. Next one is this one, solving x minus 1 all squared minus 5 is 0. Add 5 to both sides. We get x minus 1 squared is equal to 5. Square root both sides. We're going to get x minus 1 is equal to square root of 5 plus or minus. And then we add 1 to both sides and we get x is equal to 1 plus or minus root 5. Okay. Right, again, that's a pretty typical question as well. Nothing too complicated there or problem solving-y, really. Next one. So we've got our matrices here, and for this question, really, you just need to learn these matrices. So there are certain ones such as y equals x, y equals minus x. You've got your transformations as well that you just need to know. So make sure that you do know those. So this one, it says write down, again, implies you should just know it, is -1, 0, and then 0, -1. Now, obviously, if you have time, you could check this by taking a random coordinate, x, y, and seeing what happens to it when you multiply it by this matrix, -1, 0, 0, -1. And basically, you're going to get minus x on the top, and then you'd get minus y on the bottom, which if you substituted the x into here, or if we times both sides of this equation by -1, we get x is minus y, which is what we've got. Wait a second. Yes, so -1. Sorry, I've got this the wrong way around. Excuse me. I was thinking this isn't working. It's a good job I did check. This should be the other way around. So this should be -1 here. This is why you check things. This is the -1 bit here. Okay. Now I'll multiply this and I should get the right thing. So 0 times x is 0, -1 times y is -y, okay? So x goes to -y, which is what I've got up here. -1 times x is -x, 0 times y is 0. So again, y, like it says here, goes to -x, and x would go to -y, which is what we got, okay? Key point there, make sure you check what you're doing. But yeah. Hopefully that makes sense. Now this next bit, we need to do n squared. So we're going to do 0, 1, -1, 0 times by 0, 1, -1, 0. Now we do 0 times 0 is 0, and then 1 times -1 is -1. We then do -1 times 0 is 0, 0 times -1 is 0. 0 times 1 is 0, 1 times 0 is 0, -1 times 1 is -1, 0 times 0 is 0, add them together, we get -1. Now we need to describe that, and that is a rotation of 180 degrees about the origin. Okay, about 0, 0. Don't need to give a direction clockwise or anti-clockwise here because rotation 180 degrees doesn't matter which way round you go, okay? You could also say enlargement scale factor -1. And again, if you wanted to use something like x and y to multiply it by to check what that does, then do that, okay? And what I would also say is I wouldn't spend too long checking these things because they're 1 and 2 marks, not loads and loads of marks. But these are things that you should just put on flashcards, you should know, okay? Obviously, the multiplying of the matrices is a little bit more, well, you can't really put it on a flashcard per se. You need to make sure you know that, you practice it. Okay, this one, A, B, C, and D are points on a circle, centre O, angle OBC, which is this one, to angle ODC, which is this one, is in the ratio 5 to 3. So we could call this 5x, and call this one 3x, with x being one part of that ratio, essentially. How did you work out the rotation is 180 degrees? So that's one of those matrix transformations that you should know and should learn. So like I say, put it on a flashcard. The other way you could do it, so if I wanted to check this, and again, I said it was either rotation 180 degrees or scale factor -1. If we did it multiplied by x and y, we get -1 times x is -x, and then 0y. And then we've got 0 times x and -1 times y, which is -y. So what we've done there is that is -1 lots of x, y. So your scale factor there is -1, okay? And that's also acceptable. You could say enlargement scale factor -1 about the origin. That would also work, okay? So yeah, you could do it that way. just to check. And also, we know that 1, 0, 1 is the identity matrix, doesn't change it. And so this is just -1, lots of the identity matrix, so it's scaling it by -1. Okay, hopefully that makes sense. But essentially, well, the best way is to make sure we know the matrix transformations. Okay, going back to this one. So we had 5x and 3x, with x being one part of my ratio. Okay, so 5 times one part of my ratio, 3 times one part of my ratio. Now from there, I need to use the circle theorems, and I know that the angle at the center is twice the angle at the circumference. So this is 104 degrees. And then I know that this one, if I look at this full quadrilateral, that's probably a better way of saying it, opposite angles of a cyclic quadrilateral add up to 180 degrees. So what I can do is I can do 180, take away 52, and that's going to give me 128. Okay, and then from there, we have got another quadrilateral, which is OBCD, this one. Angles inside of a quadrilateral, just any quadrilateral, add to 360 degrees. So we're going to do 360 minus 104 minus 128, which is a little bit trickier to work out with our calculator. What I would do is I would use a written method to do this. So let's just do that by the side. 104 and then 128 is going to give us 4 add 8 is 12, 3, 232. Okay, take away 232. And again, you could use a written method to subtract that. We are going to get 128. Okay, then we've got to do 128 divided by 8. We're going to have to use a bus stop method to do that. Okay, so 0, 8 into 12 goes once, remainder 4. And then we've got 8 times, or 48 divided by 8 is 16. 5 lots of x, so 5 times 16 equals 80, which is what OBC is. It's 5x, it's this one here. Okay. So yeah, a little bit of working out to do in terms of adding and subtracting with that one. When you don't have a calculator, a little bit more difficult. Okay. Next one is this one, which again, with a calculator is probably not that difficult, but without a calculator, a little bit more difficult. We need to factorize this denominator. I'm going to zoom this in slightly. Yeah. We need to factorize the denominator. Do I have to know how to do long division for the non-calculator paper? Not long division. No, you can use bus stop. That should be fine. You need to know how to do algebraic division. So one of the ones I did earlier, if I scroll up, I think it was question 11. We did algebraic division here, so like this. But no, not long division with numbers. You could do just bus stop method. Okay. Right, so back to this one. We need to factorize this denominator here because we don't know if x minus 2 goes into it. Hopefully it does because we end up with this same denominator at the end. But let's factorize this denominator. So we need numbers that are going to times to make negative 24 and add to give us negative 2. So I'm thinking 6 and 4. So I'm thinking minus 6 and for positive 4 will give us the negative 2. So that denominator, let's work it out. 3x squared minus 2x minus 8 is equal to 3x squared minus 6x plus 4x minus 8. So explode in the middle. That is going to give us, when we factorize the first two terms and the last two terms, something hopefully with x minus 2 in it. So let's take out 3x from the first two green terms. So we get x, minus 2. And then for the second two terms, we're going to take out 4. And we're going to get x minus 2. Okay, so that's going to give us 3x plus 4 and x minus 2. Okay, so that's going to be the denominator here. So let's now write this out. 21x over 3x plus 4 times by x minus 2. Now, before we add or subtract them, they need to have the same denominator. So we need to times this second one here by 3x plus 4 top and bottom. So 7 lots, 3x plus 4 over 3x plus 4, x minus 2. Okay, so I'm going to put this all together and expand this at the same time. So I'm going to get 21x minus 21x, because 7 times by 3x, and we've got the minus in front. And then minus 7 times by 4 is going to be minus 28. Yep, all over 3x plus 4, x minus 2. Okay, and so that gives us a final answer of minus 28 over... See if that'll make a straight line again. It didn't. Let me do that line again. That's awful. The fraction line. Minus 28 over 3x plus 4, x minus 2. Okay, done. Scroll that down so you can actually see it. There we go. That'll be helpful. So expanded that bracket. Minus 7 times the 3x, minus 7 times the 4. 21x minus 21x minus 28, and then that simplifies to just minus 28, because 21x minus 21x cancels out. Okay. Right, we're going to look at the next one then. And again, I would say this is a fairly standard one. Okay. What we need to do here is rationalize the denominator by timesing by the conjugate. So we need to times by root 5 plus root 3 over root 5 plus root 3. Okay. Now that's going to give us, and we need to expand this as if it's like brackets here, as if we're expanding double brackets. So 3 root 5 times root 5, or root 5 times root 5 is 5, so we've got 3 times 5 is 15. 3 root 5 times root 3 is going to give us 3 root 15. And then after that, we've got root 3 times root 5, which is root 15. And then we've got root 3 times root 3, which is 3. Okay. And then that is divided by... I'm going to do that fraction line again, because that is not what I wanted. Right, so let me do a proper line. Thank you, Alexa. That's better, much better. On the bottom, we're going to get root 5 times root 5 is 5. Root 5 times root 3 is plus root 15. Minus root 3 times root 5 is minus root 15. Minus root 3 times root 3 is minus 3. So that simplifies to 18 plus 4 root 15 over, and we're going to get on the bottom, 5 minus 3, which is 2, because the root 15 and the minus root 15 cancel. And so we just divide everything by 2, and we get 9 plus 2 root 15. Okay, should be our answer. Okay. Right, moving on then to the next one. So we've got some differentiation we need to do here in order to find stationary points. Okay, so a stationary point is where your gradient is 0. And so to find where the gradient is 0, we need to differentiate, because that will give us our gradient function. So dy by dx, power comes down the front, and then we subtract 1 from the power. So 3x squared minus 3 times 2 is 6x. 2 take away 1 is 1. We're at plus 5 disappears. Now we need that to be equal to 0. So 3x squared minus 6x is equal to 0. We're going to factorize out the 3x. And then we get x minus 2. Okay, if it's not on the exam, then don't worry. But this will be helpful later on as well, because differentiation is also on the GCSE paper. We get 3x is equal to 0, in which case x is 0, or we get x minus 2 is equal to 0, in which case x is 2. Yes, that's right. Yeah, it will be on the actual GCSE, but not on the mock. We need to determine their nature, and what that means is whether they are a minimum or a maximum. Okay, and to do that, we need to differentiate again. Now, this is something which is also on the GCSE, so just be aware of that. So differentiate again. D squared y by dx squared. We are going to do 2 times by the 3 is 6. And then 2 take away 1 is 1. Okay, so we just get for that 6x and then minus 6 because this 6x differentiates to just the number in front. When you've got the x term, you just get the number left over. And then what we need to do here is we need to substitute both of these in and see what we get. So when x is 0, we have d squared y over dx squared is equal to 6 lots of 0 minus 6. So that's equal to minus 6. Now, because it's equal to minus 6, that means that what we're getting is a local maximum when x is 0, okay? Basically, if it's negative, less than 0, then it's a maximum. If it's bigger than 0, then it's a minimum. Okay, so when x equals 2, we get d squared y over dx squared is equal to 6 lots of 2 minus 6. So 6 times 2 is 12, minus 6 is 6, which is greater than 0, therefore minimum. Okay, does say minimum. It's quite hard to read because my m's quite often don't have the middle dip in them, so they just look like one straight line along the top. Okay, and we do actually need to work out the coordinates. We've got the x values, so we've got 0 and 2, but we need to work out the y values, and the way to do that is to use the original equation. Okay, so when x is equal to 0, we have y is equal to 0 minus 3 lots of zeros, it's going to be 5. Let me put that a little bit closer. So y is equal to 5. And this one, y is going to be equal to 2 cubed minus 3 lots of 2 squared plus 5. And that will give us 8. I'll write this out. 8 minus 3 times 4 is 12 plus 5. 8 minus 12 is minus 4. Add the 5 is 1. Okay, so we get 2 and 1. 2 and 1, 0 and 5. And when x is 0, we've got a maximum. And when it's 2, we have a minimum. I'm trying to remember how to spell that word. Lots of M's. Okay. So there we go. Not the most straightforward one, but it's something that's also on the GCSE as well. The IGCSE, that is. Okay, moving on to the next question. Now, for this question, we've got a graph of y equals minus x squared plus 3x plus 6 from minus 2 to 5. So if we go down, the actual question is this: by drawing a suitable straight line, work out approximate solutions to this. Now, what we want to do is we want where, obviously, this is equal to 0. And so what I want to do is I want to write out, basically, I want to work out a way that I can get on one side of the equation this, and on the other side of the equation, I will have something else, some straight line, which I can then plot. Now, what I'm going to quickly do, and this isn't the easiest one to work out and could quite easily go wrong, because this is negative x squared and this is positive x squared. Now, I need to, basically what I'm going to do is I'm going to put this negative, I'm going to put this x squared on the other side of the equals, and then it will become negative. But if I do that, I need to do with everything else. And so if I think about what I've got here, if this was positive, I'd have x squared, or sorry, change the signs, not positive. I'd change the signs of everything. I'm going to have x squared minus 3x minus 6. Okay, so if I go back down to here, I need to have x squared, let me scroll back up, I forgot what I put, minus 3x minus 6. Minus 3x minus 6. And then I'm going to have something else, and then I'm going to have equals 0. And I'm going to put all of this, once I've worked out what else I need, on the other side. And then I'll have something left over here, which I'm going to plot, and it'll make a little bit more sense in a second. So I've got minus 3x, I need minus 7 over 2x. 3 is 6 over 2, and so I need to minus a half x. To get from minus 6 to minus 3, I need to add 3. Now, if I put all of this on the other side, I'm going to get this. Minus a half x plus 3 is equal to minus x squared plus 3x plus 6. Okay, which is what's already plotted. Okay, minus x squared plus 3x plus 6. Okay. Now, to make this explanation a little bit easier, and this is not the easiest question of this type that I've seen, to be honest. So if it's a little bit confusing at the minute, I could understand why, even if you're someone who's practiced this question before. If I put y in the middle, well, this is what's plotted. Okay, now if I plot this, where those two cross over or intersect with each other would be the solution to this equation. Okay, and obviously on the left-hand side here, I've got a straight line. On the right-hand side, I've got what's already plotted. So I need to plot y equals minus a half x plus 3. And you can do that. Well, I was going to say you can do it with the table function. You can't do that with the table function. What we could do is we could look for when x equals 0, what y is, and when y equals 0, what x is. And that will give us 2 points to then work out what the intersection is. Explain the first line a little bit more. So this bit here is what I want to put on the other side, which I put here, so that I get the original equation that is plotted. Now, basically, essentially, with these questions, what you need is you need on one side of the equals, which is what we have got here, the line that's originally plotted, and on the other side of the equals, you need something else that you're then going to draw. Now, that needs to, when you put it all together, give you the thing that you are trying to solve. Where did the minus a half x come from? Good question. So I have here minus 3x. I need to make minus 7 over 2x. So minus 3 minus a half is minus 3.5, which is what 7 over 2 is. 7 over 2 is 3.5. So I basically worked out what I needed to add or subtract from the minus 3x to give me the minus 7 over 2x. So you're basically trying to break this apart into something that is we've already been given, that is already plotted, and then work out what you need extra, what you need to add or subtract from that to give you the thing you're trying to solve. So like I say, this isn't the easiest problem of this type that I've seen, really, because what you need to do is put this bit on the other side to then make it all the opposite signs. So yeah, it's not the easiest. The other thing you could do is put all of this on the right hand side first of all and get minus x squared plus 3x plus 6, work out what you need to add, and then put that on the other side, and then you get minus a half x plus 3, which is then what we're going to plot. Essentially, you need to break it apart into something which is already plotted and whatever else you need to make the thing you're trying to solve. Yeah. Hopefully that's helped explain it. If it hasn't, what I would suggest is trying to look for similar problems on Maths Genie, which are a little bit easier to understand. I mean, if I try and give you an easier one now, so let's say I've got y equals x squared, that's plotted, and I want to know the solution to 0 equals x squared plus, I can't do plus, that won't work, x squared minus 2 using this graph and plotting a line on it. Well, I've already got y equals x squared, so what I would need to do is I would need to add the 2 to both sides, so I get 2 equals x squared. I would then write it as 2 equals y equals x squared. This bit is already plotted, so what I need to do is plot y equals 2, and where that intersects with the line would be my solution. So then what I'd do is I would do a straight line that basically goes through the y-axis at 2. Okay, and then these intersection points would be my solution to this. Okay, so that's an easier example that may make more sense. They're not always as complicated as the one in this question. Like I said, hopefully that makes more sense. I'm going to get rid of that other example here a second now. Right, so going back to this, I'm looking at plotting this line. This is what I need to plot. And without a calculator, I'm going to need to work out at least 2 values it goes through to plot it. So, if x is 0, y is 3. How do you find the coordinates of the solutions? I'm going to show you now. Basically, we plot this line, we draw it, where they intersect would be the solutions. I couldn't do that on the example I just did because it wasn't actually on a grid. So, yeah, I couldn't do it just from that. But I'll show you on the one above in a second. So, if y is 0, I'm going to have to do some working out over here. We get minus a half x plus 3 equals 0. Put the half x on the other side, we get 3 is equal to a half x, times both sides by 2, and we get x is equal to 6. Okay, so now we've got 2 coordinates to plot. We're going to draw a straight line through them, and then we're going to use the intersection points to estimate the solution. Okay, so x equals 0, y equals 3. X equals 0, y equals 3, that's here. And then the other one, x equals 6, y equals 0. So that's going to be here. Okay, we're going to draw a straight line through those points. I'm going to have to extend my line. And then where they intersect, so here is my x value solution, and here. So this would be 4.2. And then this one, I reckon, is about, well, that would be minus 0.5. I reckon this is minus 0.75. Okay, it's about here. So minus 0.75 and 4.2. Okay, so minus 0.75. I'll just check that's what they want. Yeah, work out approximate solutions. Okay. Now the mark scheme gives you a range. So on the mark scheme, it gives us from minus 0.6 to minus 0.8. And then the other solution from 4.1 to 4.3. Okay, so you do get a range of values for that in case you don't quite draw your line correctly. Okay, they're aware of obviously the fact that you can't just do loads and loads of points because it would take up loads of time as well. Right, question 21, quite a nice question because it's to do with indices, and I quite like indices personally. Now here we've got an index inside and outside your brackets, so we need to multiply them. So let's do that bit first and not rush it too much so we don't make a mistake. X times 4x is 4x squared, and then we've got x times 1, which is x, 3 times 4x, which is 12x, and then we've got 3 times 1, which is 3, so that is 4x squared plus 13x plus 3, So we get 2 to the power of 4x squared plus 13x plus 3 is equal to, now 8 I can write as 2 cubed, and then to the power of x minus 1. So that would be 2 to the power of 3 brackets x minus 1, because you've got to time them together. Now, because we've got here the same base, that means the powers must be equal to each other. So that means 4x squared plus 13x plus 3 is equal to, let's expand this at the same time, 3x minus 3. Okay. Take away the 3x from both sides. We are going to get 10x. Add the 3, we get 6 equals 0. We're going to divide everything by 2 because they're all even numbers. People are laughing and reacting. Appreciate it. I don't know why I've said this funny, but thank you anyway. And then plus 3 equals 0. Okay, divide everything by 2. Then from there, we need to explode the middle or split the middle again. So 2 times 3 is 6. Factors of 6 that add to 5 is going to be 2 and 3. So 2x squared plus 2x plus 3x plus 3. And then we're going to factorize the first 2 terms here, and we're going to factorize the second 2 terms here. So that is going to give us 2x, x plus 1, and then plus 3, brackets x plus 1, equals 0. So we get 2x plus 3, and then brackets x plus 1. Just the happiness that comes from maths. Good. I like to hear it. So 2x plus 3, x plus 1 equals 0. Let's just check if this did say solve it. Possible values of x. So x is going to be minus 3 over 2, which is minus 1.5, or x is equal to minus 1. Okay, so they are our solutions. Okay, moving on to the next one then. Okay, this question. So it's not a nice looking question, and actually is not the easiest question either. So basically, what I did, and I'll be totally honest, is I tried this question beforehand. EdXLI, GCSE, further maths, I find them quite difficult. Okay, yeah, I can do that in another stream. So I'm doing a stream tomorrow, which is any papers, any questions. So I will have a look at some EdXLI, GCSE, further maths as well. If there's any questions in particular you want me to have a go at and to solve, let me know. But tomorrow will be just whatever people want me to do further maths related, basically. Okay, back to this question. Yeah, I tried this question before because it looks quite interesting, and I'm being totally honest. Sometimes I'm not able to, and everyone will be like this. You look at a question and you've got to try a few different ways, and you don't always see how to do it straight away because you're not going to be able to. They're problem-solving questions, particularly at the end of these papers. Okay. And what I did is what I'd recommend you to do if you see a question like this. Write down the identities that you know. The sine squared plus cos squared is 1. Okay, sine over cos is equal to tan. Okay. Yes, if trig identities isn't on your mock, then yes, this won't be on the mock. Now, these are the main trig identities you need to know for further maths AQA. And looking at this, it's quite difficult to see where you could use these. But one thing we can do is we can either factorize the top and the bottom, or the first thing that I did, or actually, I say not the first thing. It wasn't one of the first things, but one thing that works for me was, well, I can divide this by cos squared. If I divide this by cos squared here, I'm going to get sine over cos, which is tan. This would be tan squared. This divided by cos squared would be 1. It would cancel. This divided by cos squared would be sine over cos, which is tan. So if I divide everything here by cos squared, what I get is 3 tan x plus tan squared x, all divided by, and then on the bottom we are going to get 12 plus, and then we're going to get sine over cos, because divide by cos squared, that'll cancel, then we'll get over cos, so we'll get 4 tan x. Now from there, what we can do is we can cancel by factorising. So if we factorise out the top, if we do tan x out of the top, we are going to get 3 plus tan x. Okay. Now from there, what we are going to get is, if we do this, on the bottom, we can factorise out 4, and we are going to get 3 plus tan x again. Okay. Now, I can then cancel these brackets, and we're going to get tan x over 4. 150 over 160 on my GCSE further maths this year. Well done, that's very good. Tan x over 4 is equal to this minus 3 over 4. Minus root 3 over 4, I should say. Very good, very good. Yeah. Timesing both sides by 4 here, we get tan x is equal to minus root 3. And then we're at this point where we need to start thinking about the triangles and about our tan graph, okay? So, if I just do a quick sketch of the tan graph. Oh, let's do it like this. We need between 90 and 180. Now, your tan graph is going to go up like this. We're going to have an asymptote at 90. So that would be at 90. It's down at 270. And then we've then got 360. And so your tan graph is going to come up like this. We go through there at 180 and carry on going up. Okay, and then it will come up from the bottom and up to 360 like this. We've got an asymptote here as well. Okay, not the best drawing, but you get the idea, and that's what you need to know. Okay, you need to know what it looks like. Now, if we zoom in on this a little bit, we need to know about minus root 3. Now, minus root 3 in our solution is going to be down here somewhere. Minus root 3 is about minus 1.7. So let's say it's here. It doesn't really matter. Okay. Now, you could remember about the tan function, what you need to add on, what you need to subtract. I generally don't do that. I use the graphs. So here, this distance, and I'll try and highlight this, that distance there has to be the same as if we'd flipped it and we were looking up here. So this distance here has to be the same. Okay, so we've got from here to here, that has to be the same as from there to there. Okay, now what that then means is this would be at the same height. This would be at a height of root 3. Okay, because of the symmetry, you know, we can take this bit here, we can flip it up and reflect it. Okay, and so that would be at a height of root 3 because of the symmetry of your graphs, essentially. So really what we need to do now is we need to find out what tan of root 3 is. And to do that, I'm going to zoom out, we need to think about, well, you can either learn these or you can remember the triangles. I'm going to go through the triangles. Now the one for root 3 is the equilateral one. So I'm just going to do a quick sketch. So we've got our equilateral triangle here, width 2. Okay, all of your angles are 60. And I'm going to drop a perpendicular here. And then that would make the width 1 and 1. And would also bisect this angle to make an angle of 30 degrees. Now, then using Pythagoras, this height would be 2 squared, which is 4, minus 1 squared, which is 3. And you square root it, and so we get root 3 here. Now, tan is opposite over adjacent. So we need to do opposite the 60 over adjacent, which is 1, root 3 over 1. And so we know that tan 60 is equal to root 3. And that might be something you just learn anyway. And what that tells us is that up to here is 60. Okay, so from there to 90 is 30. Okay, 60 to 90 is a distance of 30. Add the 30 on the other side, we're going to get 120. So to get minus root 3, x needs to be 120 degrees. So like I said, that is a distance of 30 here. So you do 90, add your 30. Okay. Quite a complicated question. Again, it's at the end of the further maths paper. It is not going to be the easiest question. Okay. But that's how you do that. And that would have taken me a little bit of time to work out. It's not something which is straightforward, which you're going to get straight away. There are going to be problem-solving questions there. Right. Moving on, and I think this is the last question here. Right. Now, this, again, to be totally honest, I had a go at that last one before. Didn't have a go at this one. So, and this is the last question. We'll see how this goes, and it might take me a little bit longer than just straight away. It's 5 marks. We'll see what happens. What I would say is quadratic sequences, you look at the second differences, and we want to end up with this. Okay, so I'm going to write this out again. 2x 16y. We know that this difference here would be it would be x minus 2. Okay. What time do I usually start my live streams? It changes every time, but I usually try and schedule them so you can see. It's something I'm doing at the minute, really, because the students at my school are doing the mocks. So, yeah, that's what I'm doing at the minute, but I'll schedule them so you can see. It's something I can do in future as well. This next one, we'd add 16 and take away x. And then this one here, we would add y and minus 16. Now, because it is a quadratic sequence, it's the second difference that needs to be the same. So this difference here, well, this would be 16 minus x. For this question, how do we figure out whether this is arithmetic or geometric for the sequence? So it says quadratic here. Okay, so if it's a quadratic sequence, it's going to be not arithmetic or geometric, it's going to be going up, but the differences will be increasing as well, or decreasing, depending on which way it's going. But essentially, it won't be this first difference that's the same, because that will be arithmetic, it'll be the second difference. So, we're going to do 16 minus x minus 2. That would have to be the same as this difference here. And actually, what I'm going to do is I'm going to move this down a little bit so we've got some space. So let's put that over there. That has to be equal to y minus 16 minus 16 minus x. Okay. Right, so we've got that, and those two things have to be equal to each other. So let's do that first of all and rearrange that to make something a little bit neater. So on the left-hand side, we're going to get 16, actually, yeah, we'll leave it like that. 16 minus x, and then plus 2 is equal to y minus 16 plus x. So from there, we're going to get 16, it's not 16, I'll do 18, that would make it a bit better, so collect my like terms properly. 18 minus 2x is equal to y minus 32 plus x. We're going to take away the x from both sides, and we're going to add 32. 32 add 18 is going to be 42 add 8, which is 50. Minus 3x is equal to y. Okay, so we've got this. That's going to be important in a second. We know that the middle term is minus 5n. Okay, so that's going to be important. Now, okay. What I'm going to do is I'm going to explain how normally something like this would work. Actually, I'm just thinking I could do it that way and work it through as if it was a normal problem. Or what we could do is we could substitute in here for 1 and for 3, and we could set these equal to, and then we've got some simultaneous equations with A and C. And so actually, maybe I didn't even need to do this first bit. But like I say, this is sometimes what happens. Maybe you try something and it's not that it's wrong, this is right, it's just there's another way to get the answer, and actually probably this is just going down a dead end, but yeah, we'll see. So what I'm going to do is, I'm going to substitute in here. So I'm going to say this is my first term, second term, third term, fourth term. If n is 1, so let's do this up here, we get a minus 5 plus c. Okay, and that has to be equal to 2, because that's our first term. 1 squared is 1 times a is a, minus 5 times 1 plus c. Let's rearrange that slightly to get a plus c is equal to 7. Okay, and then I'm going to run out of room here, so I'm going to move this down here. Let's move this down. And then what we're going to do is let's do... Oh, I've gone right back up to the top. That's not helpful. Let's go all the way back down here. So let's do n is equal to 3. And we are going to get, if I scroll back up, we have got... Let me just slide this along slightly. A times 3 squared, so we're going to get 9a minus 5 times 3, so that is minus 15 plus c, and our third term is 16, is equal to 16. So we're going to get 9a plus c is equal to 31, and then this is our second equation here, and then a plus c equals 7 is our other one. I'm going to label these 1 and 2. I'm going to subtract the first one from the second one, so I'll need a bit more space here. Let's do equation 2 minus equation 1. And we are going to get 31, well actually 9a take a is 8a. C take c cancels. 31 take away 7, 30 take away 6 is 24. So a is equal to 3. And then I'll just do the other bit over here. So if a is equal to 3, we've got a plus c equals 7. So 3 plus c is equal to 7. So we've got c is equal to 4. Okay, so let's go back up and see what the question actually wants. It says x equals y equals here. For an alternate solution, couldn't we substitute the x value we calculated for y back into the original sequence and do the whole term 2 minus term 1 equals term 4 minus term 3 again? Potentially, but you may end up with something which is equal to itself again. So potentially, but I feel like because I obtained it via that method, if you plug it back in, we're going to end up with the same problem. We're going to end up with something which is equal to something. Like you'd end up with a situation where you get something like 2 equals 2 or x equals x. And so it doesn't actually help you. But potentially, what I was thinking when I got to this point is that I need another equation to then solve. Because if you've got 2 variables, you need 2 equations to solve it. But yeah, that's what I think would have happened. Right, so we got to this bit. A is 3, C is 4. Let's put it back into here. So A, what did I say? A is 3, C is 4. 3n squared minus 5n plus 4. And then we need x and y, so we need the second term and we need the fourth term. So 3 times 2 minus, let's write this down here. So 3n squared minus 5n plus 4. We need where n is 2 and n is 4. So we're going to get 3 lots of 2 squared minus 5 lots of 2 plus 4. 4 times 3 is 12, minus 10, which is 2, plus 4 is 6. We will check this in a second as well. And then we're going to get, I'll just put it up here for the second, so 6. 3 lots of 4 squared minus 5 lots of 4 plus 4. Yeah, it is much better, isn't it? I do agree. Like I say, sometimes it works out that you see a better solution, but not always straight away. And yeah, so, but that's hopefully part of the way that I want to do things anyway. Is not, I don't want to just copy it from a marks scheme. I want you to see and people watching to see actually how it's done, and not to just think, oh, you should just get it straight away, because you don't always see it straight away. And you've got to struggle a little bit sometimes with the math problems. Anyway, 4 squared is 16 times 3 is 48 minus 20 plus 4. So we're going to get there. 48 take away 20 is 28 plus 4 is 32. So let's check this. So we've got 6 and 32. Let's go back up and see if the second difference is the same. So we've got 2, and then it was 6, and then it was 16, and then it was 32. So that's going up here by 4. That's going up by 10. That's going up by 16. And our second difference, well, that's 6, and that's going up by 6 as well. So yeah, it works. It's right. Okay, you can see your second difference is the same, which is what it should be. So there we go, 6 and 32. A little bit messy because I tried a different method up here. It didn't, well, it may have worked, but I could see a different, easier method that worked better. So just double check that with the mark scheme, that's right. Okay, hopefully that was helpful and useful. If you enjoyed the video, please drop a like on the video. Thank you very much if you stayed this long. Like I say, hopefully it was useful. We'll be doing another stream tomorrow. Don't know what time yet. What day is it tomorrow? It's Wednesday. I can do I'll probably do same time. Let's say 7:30, then I can have dinner first as well, hopefully. But yeah, hopefully that was useful, and I'll see you tomorrow if you want to come back. And I'll just go through some general questions, some general problems anybody's got, put them in the chat, and I'll go through any question, any paper, for the maths. Okay, thank you very much for watching. I might see you tomorrow. Otherwise, yeah, see ya. Bye-bye.